Humans living for 900 years in the Bible. You're kidding, right?
Certainly it's surprising data, but I do think that it's very reasonable based on history, based on the text itself and the nature of that text, and based on biology, to believe that we're reading real data, that we're reading real history. We know that ageing can be sped up, sadly, because of mutations. We know that there are animals that can live for over 4,000 years. So biologically, there's no basic reason why ageing needs to be something that causes humans to die at a certain particular point in time. It's not just wear and tear.
After Noah's flood, people lived shorter and shorter lives. Why is that?
Yes. Well,
today we're asking a question that sounds like it is straight out of science fiction. Did people really live to 900 years old? Jonathan Clerke, I want to get straight into this. Where does it come from? It's in the Bible. So I'm going to read a little passage and I want to hear what you think.
okay.
Genesis 5 verses 25 to 27 says, "When Methuselah had lived 187 years, he fathered Lamech. Methuselah lived after he fathered Lamech 782 years and had other sons and daughters. Thus all the days of Methuselah were 969 years, and he died." So we've got someone living to 187, having children then, and still going on to live to 969 years old. Now, I know you've done a lot of physiotherapy over the years. You've got 30 years experience. You know the human body and how it works. How could we possibly have people living for such a long time?
Well, you're certainly right. The bodies that I've treated weren't going to even make it to 100 years, I think, in most cases, unfortunately. But back then, I do think that it's very reasonable, based on history, based on the text itself and the nature of that text, and based on biology, that to believe that we're reading real data, that we're reading real history.
Okay, well, let's just get the big picture here. The Bible. It starts with old ages, and then somehow today we've got relatively younger ages.
Yeah.
By a factor of 800 odd years.
That's right.
So how many people lived that long? When did it change? Just give us a bit of an overview.
Great question. So you're right, most of this data is in the first book of the Bible called Genesis, and you're reading from Genesis chapter 5. And so far what's happened is the historical retelling of God making the world in 6 days. He made every living creature, and we were included in that package. And originally we were made to live forever. That's what the Bible says, as fantastic as that may seem. Unfortunately, Adam and Eve chose to disobey God, and as a result of that, the ability to live forever stopped. For generations after that, for about 10 generations, we read in the Bible what I think is an historical actual data about a lot of people reaching to the age of 900 and plus. In fact, on average, that first group of people of about 10 generations lived on average about 912 years. Yeah, I hope they had physios. But that's a crazy thing. They didn't seem to have bodies that were like our bodies. We're not talking about people at the age of 500 looking like an Australian today or an American or anybody else at the age of 90. We are talking about a very different ageing process, not necessarily one that kicked in later, but certainly an ageing, not necessarily that they aged earlier or aged later, but rather that they lived longer and lived healthily. But after those first 1,500, 1,600 years, about 10 generations of people, we see this drop in the ages. And because this is happening over a long periods of time, this is spread throughout several books in the Bible. And if you map out that data, it looks very unusual. So you've got this group of people, if you imagine a graph, all living about 900 years. And on the x-axis, we've got the bottom axis, we've got the number of generations. And then along comes a flood, and suddenly their ages start to precipitously drop in what looks like, to most biologists, an exponential decay curve. That's just a fancy way of saying it started to drop off quickly and then it started to flatten out. So the first few generations, their ability to live a long period of time, quickly dropped off, and then it plateaued out to about where we are today. So that's a big picture. And I know some people will, if they're hearing this for the first time or even the 100th time, are still going to say, give me some reasons to believe this, because I'm thinking this is a bit of a strange book, seeing it also talks about Jesus.
Yeah, I've already got some questions here. So that's one historical source.
Yes.
Or you're saying it's a historical source, the Bible. But
Yeah.
are there any other historical sources to indicate that people did live for a long time back in the past?
Yeah, there is. There's a guy called Josephus. So he was a historian born about 37 AD. So if you think of Jesus being crucified roughly around 33 AD, he was pretty hot on the heels of Jesus' death and resurrection. Josephus was a really interesting character. He was a Jew. He was part of the group that was meant to be resisting the Roman invading army, or rather the Romans trying to take back over the city that the Jews were rebelling in. And in the end, he ended up working with the Romans, which is quite a big flip when you were a general and a priest and of royal blood, that you actually start working with the Romans. And in that capacity, he then got their favour, and he was able to write massive history books. One of them's called Antiquity of the Jews, or Antiquities of the Jews. And it's a really big work. Interesting read. If you can find a modern English version, it'll be quite fascinating reading. It really helps you get into an understanding of what life was like back then.
So was that originally written in Greek? Or
Yeah, it would
Greek,
have been
was it?
originally written in Greek.
Yeah.
And in that book, like many historians, he quotes other historians. In fact, he quotes about 55 others. The best part about this is some of the people that he quotes, their material is still existent, just like his material. Now, when I say Antiquities of the Jews is still existent today, I don't mean the original, I mean a copy of that, and the same with the others. So we've been able to test how faithful this guy is to his source material when he's not writing about eyewitness things. So he did write about a lot of what he saw, but he also wrote a lot about what other people had recounted, because he was giving a big history. Big picture history. And so as part of that, he's trying to help the Romans, who are the rulers, see that his religion, the Jewish religion, which only has what we call the Old Testament as their Bible, is not so strange as he might first think. That's the setting or the context of what I'm about to say. And in that setting, he says that our books, our history books, if you like, tell us that the first generations of people, those ancient people, used to live for around 1,000 years. And then he says, and your historians say the same. And he names 11 different historians who he claims all will back him up. And then he says, you can go and read their books and check if you think I'm making this up. So that's rather exciting that he was able to name individual historians who all believe that once upon a time, humans lived for about 8,000 years, not 5,000 or 10,000 or even 3,000. It was quite precise. So then the big question is, well, how good was Josephus quoting from these people? Unfortunately, all those books that would have mentioned that data, we don't have them. But we at least have a way of testing how faithful he is to his sources. And in general, he's very faithful.
Thanks for watching the interview so far. Just a quick one. If you haven't already, make sure you click that subscribe button so you can see more of this content. Back to the interview. So he's a good historian.
A good historian that way.
He checks his sources and from what we know, from what we have available.
That's right.
And it's interesting you said 1,000 years, because I mean, the average, for the first 10 or so generations in the Bible we read, they're all around that 900 mark, which is very close. Like that's a ballpark area. That's similar sort of numbers. So that's fascinating.
But I want to add something else though. Like all of us, he had a bias. And that bias sometimes does change the periphery of the big picture. Sometimes it can change more. But I think in this particular case, it's worth noting that in general his bias was to minimise what the Bible said about God's interventions.
Oh, right.
So he's not trying to tell the Romans, our God is such an intervening great God. He did all these amazing things. Generally, he's minimizing God's interventions because he's trying to appeal to the Romans, who, although they had many gods, in general, those gods weren't what we would call big, intervening gods. So he's playing that down. And yet he still says that the Bible records these people as living over 1,000 years. So he's not, if anything, you would think that if he was biased, he would have exaggerated that figure to say they lived for 5,000 years because these were the best of the best people. Our ancestors were so great. But
Make
no.
him sound really important.
Yeah, yes. So given what little we know about his bias, there's no indication that would have twisted what he was saying about his source material. And as I said, in general, he quotes from his source material very faithfully.
Okay, so from a historical point of view and sources and texts, it seems like, that's what people thought. But let's have a look at the biology, because we know a lot about biology today.
Yes.
And one thing we generally know, I think we know pretty well, is that people don't live that long anymore.
Yeah.
Tell me about biology and how does that relate to long or short life?
Sure. This is a big story, so I'm glad you got the time. So it's an exciting story too. So the first thing that most people get surprised at is that in as late as 2019, in what's called what is a very prestigious international scientific journal, it's called the Proceedings of the National Academy of Sciences of the United States of America. In 2019, there was an article, and one of its first words is, we don't have a good understanding of ageing. So although a lot of people might think that, ageing's easy to understand, we just wear out.
Yeah.
The reality is ageing is not mostly about wearing out. We might feel it in our teeth. If you grind your teeth at night, yes, they will wear out. But in general, the big biological picture is it's not so simple. There's a lot of genetic involvement in our ageing process.
Right. Well, let's start even simpler. Are there any other creatures? So we've got humans live to maybe 120 if they're really lucky today. Are there other creatures that live, for instance, I think I remember hearing about a giant tortoise that lived a long time. Are there other creatures that give us a bit of insight into the possibility of long life?
Oh, definitely. So we can start off with some small creatures. So a lot of people like eating mussels. So they're basically a clam. And so they're a bivalve clam, typically. And there's one of those that's called Arctica islandica or islandica. Obviously, you can tell by the genus name Arctica, it lives in cold places.
Yeah.
In 2006, off Iceland, they dredged one up, and it's actually been given a name, just this one clam. It's called Ming. And it's because when it's big for its species, colloquially it's called an ocean quahog. And this one here, this ocean quahog, it's 87 millimetres in size, which we think is small, but most of the others have been more around the 50 millimetre mark. And they aged this one, they worked out its age, and they said it was 507 years old.
Wow.
Now, you might think, maybe it's really simple. Well, it's not, because it's made up of a variety of cells, so they're our building blocks. So you think of a house, it might be made of some standard bricks, and then it might be made out of bigger, better blocks or other type of concrete bricks. Yeah. Our bodies are the same. They're made of all different types of bricks and millions of each type. And so
these are the cells.
These are the cells that make what I'm seeing of you and you're seeing of me, apart from our clothes. We're just a combination of masses of numbers of cells and quite a number of types of cells. So muscles are the same. This ocean quahog is also complicated. It's got different cell types, and each cell is super complicated. Some people would say the best analogy to a single cell is it's more complicated than the biggest city on earth, and everything moves a lot faster. Wow. And yet this little creature, this little fellow called Ming, maybe it's a boy, maybe it's a girl, was dated at 507 years of age when it died.
Wow.
Someone killed it, actually.
Oh, right. So it might have been able to keep going.
Yes. You might think you can live to 80, and that might be true, but if someone hits you with a bus, you're going to die then.
That's true.
Yeah.
Yeah. Are there any other creatures that live for very long amount of time?
You want very long? Yes, there is. So we're in Queensland at the moment, so some people would know that what makes Queensland famous is our coral reef.
Oh, the Great Barrier Reef.
The Great Barrier Reef, it's terrific. It's really beautiful. And at the Great Barrier Reef, we like to skin dive or scuba dive or snorkel and look at all the beautiful corals. And we know, therefore, typically that corals are very shallow creatures. But the reality is corals are also carnivores. They're happy little carnivores. They like to have their bit of meat, not just their veggies. And some corals are deep sea corals. And there's a group of deep sea corals that include a species called Liopathies, that's its genus, Liopathies glaberrima. And these grow very deep. In fact, from 100 metres down below the surface to over 2 kilometres below the surface.
Wow.
One of those, off Hawaii, they say is 4,200 years old, this one animal. Wow. So that's a long time.
That's very long.
Yeah.
Yeah. And I mean, those are, so you've named a type of mussel and a coral. They're a little bit, I mean, they're a lot different to humans, put it that way. They're creatures that are a little more similar, like, larger creatures that have lived for a long time.
Sure. So let's stick to the marine environment. One of the other things that we swim with at the Great Barrier Reef is sharks. And some of them can be big, but their tummies are full of eating lots of fish. So we know our sharks pretty well. There's a shark off Greenland called, strangely enough, the Greenland shark.
Makes sense.
Makes sense. And its Latin name is Somniosus microcephalus. It just means it's sleepy, that's the first bit, and it's got a small head. So it's probably why it always looks like it's smiling, my wife says, because it's quite simple and it's getting plenty of sleep. It's got a small brain. So anyway, Somniosus microcephalus, a big shark. So we measure sharks from the tip of their nose to where their tail forks. This one's often 5 metres long. So it's a big animal.
Yeah.
They think that the average lifespan for a bunch of them that they caught was 390 years, with the possibility that some of them were living to 500. Now, what's fascinating is, so this is a Somniosus microcephalus. So just think of the dogs, Canis familiaris. So Canis means it's of that genus. Familiaris means it's a dog that we're familiar with, I guess. Yeah. But there are other dogs that look like dogs, but they're a different species. So there's another shark that's also a Somniosus, but it's a different species called Pacifica. So we've talked about Somniosus with the small head, microcephalus. And now we're talking about Somniosus pacifica.
So it's Greenland shark and the Pacific.
You could call it Pacific,
it's a different one.
Pacific, like the Pacific Ocean.
Yeah.
It looks like it might only live to, at most, a third of the lifespan of Somniosus. So two very similar looking creatures. Like us, they both have spines, but their spines are made of cartilage instead of bones. They have jaws like we have jaws. They have a liver like we have a liver. They don't have a swim bladder, just like we don't have a swim bladder. But they are a chondrichthy. They're certainly not like us in some other ways.
Yeah.
But a big animal living for a long time.
So just so people understand, you've been talking a lot about very in-depth and in detail biology, and you've got background in zoology and I can't remember what the other one was called.
Parasitology.
Parasitology.
Unfortunately, many people think it's parapsychology, but no, I don't study ghosts. Parasitology. So I worked in that area of studying those sorts of diseases for a number of years before I eventually moved over to physiotherapy.
Right.
Working my way through all the professions that start with P.
Yeah. Sounds good. Now, we're talking about sharks, but they do have a lot more similarities than the coral, but they don't breathe air the same way. Like, I wonder, are there any air-breathing creatures that can live a long time?
Yes, there is. So we're technically called mammals. Christians believe that we're not just an animal, that we have something more supernaturally that makes us different, so spirit. But we are a mammal. So that means we've got hair, that when we were babies we need to suckle from our mothers. And equally, there's a creature that most people don't realise that is a mammal, that is a whale. And in particular, there's one whale called the bowhead whale. And this is a big whale, really big. Its scientific name is Balena mysticetus. But the important thing for our discussion is that it's a mammal like us in many ways. And it lives for perhaps 200 years.
Wow.
Yeah, providing no one kills it and puts that up on your dinner plate.
Yeah.
But yeah, so its lifespan is about 200 years. So there's an example of a big mammal. It's not 500 years old, but it's 200 years old.
Yeah. All right. Well, we've got a lot of different living creatures that can live for a long time. A lot of biological examples of long life.
Yes.
But there must be something, that's, I don't know, maybe at a more fundamental level that means that allows them to live for this long. Can you talk about the biology of
sure.
why do they live this long?
Yes. Well, it's to do with the genetics, we believe. I mentioned before that it's probably not to do with wear and tear of our bodies. It's mostly, it seems to be a genetic process. When this genetic process is uncorrupted, it looks like it can make creatures live forever. So there's a real small animal that's only about 10 millimetres to 30 millimetres long. It's called a hydra. Scientists believe that providing something doesn't eat it, it could well be immortal. So what is it about genetics that allows one Somniosus species to live for maybe 400 to 500 years, but a nearby species only living for 70? And the clue seems to be with telomeres.
Telomeres.
Yeah, telomeres.
Okay.
So most people probably know that our cells consist of part of each cell consists of a nucleus, and in that nucleus we have our DNA, which a lot of people know looks like a twisted rope ladder, really. And that twisted rope ladder has a language written on it, speaking analogically. And this language consists of 4 letters. And so although it's only 4 letters, it's still a very complicated language. You think of computer language, it's only 2 letters, and yet we can make a very complicated piece of language on it, can't we?
I remember I did electrical engineering at uni, and we did some computer programming, and we actually went down to like some AND and OR gates and binary, and it's amazing how much complexity you can get even from a simple system.
Yes.
So like that's 2. To me, I go, 4, okay, that can be very complex too.
Yeah, it is. And these letters are numerous. So if you were to put all our DNA in one big line, there's 3,200 million letters just along one rung of the twisted rope ladder, one side of the twisted rope ladder. So there's a lot of letters there, but there's only 4 options, C, T, A, and G. And so these in our body, this big lot of DNA is in smaller bits. And each bit, like as I said, looks like a twisted rope ladder. Each one end of that ladder needs what we call a telomere. So think of your shoelace, an old-fashioned shoelace that's made of fibres, threads. At the end of it, you'll find a plastic cap, which we call an aglet. And it's used to tighten up the loose ends of your shoelace so that your shoelace doesn't completely unravel. And that's basically the functionality of the ends of the DNA that we call telomeres. They consist of a bunch of repeated letters over and over again. So think of the letters T, T, A, and then G, G, G. And then imagine that set of letters, that's 2 words, 2 codons, is repeated over and over and over again for thousands of times. And then imagine that it's wrapped up in plastic. And that's a protein that goes around the outside that is important for maintaining it. So there's 2 things we need to keep our eye on. How long is our aglet? How long is the end of our shoelace? And how good is the quality of that end? And that protein that wraps around the end is very complicated. In fact, the shell pterin, as we call it, consists of 6 proteins, and just one of those consists of 630 amino acids for the biologically minded people listening to us.
Yeah.
So these aren't simple ends, but they're very critical for the aging process.
Right. So telomeres, this is what makes sense to me, your shoelace analogy. And you've got a cap on the end, and that the quality and the length of that cap is important for aging? Is that what you're saying?
It's important to ward off aging, is more importantly.
Right.
So all our cells in our body, or most of the cells in our body, they need to continually divide. So by the time you're a certain age, just about every cell in your body is not the same cell that it was when you were born, because those cells that you were born with, many of them have died. Many of those cells have died and been replaced because of the ongoing process of your cells reproducing themselves. So you might reproduce yourself in the sense of having children through your wife, but we also reproduce various body parts. And every time a cell divides in two, unfortunately for us humans and many other creatures, the telomeres shorten. And there's probably also a bit of degradation of that protective plastic coating in a protein. So when we're born, we have about 11,000 repeats of these two words. Remember I talked about the two codons, or two words, the TTA and then the GGG?
Oh, yeah, so they're codons.
Yeah, they're codons.
Yep.
Imagine that when you're, well, not imagine, when you're born, there's a cell in your body that has that repeated 11,000 times at the end of your DNA, each strand of DNA that ends in a free ending. So that's a lot.
So the telomere is long when it's nice and long when you're born.
Yeah, nice and long when you're born.
Okay.
When you're 20 years old, and you look to me like you might have missed that boat already. When you're 20 years old, it's already reduced down to about 8,000 for a particular cell in your body.
Right.
And so when they get critically short, that cell will age. And if all the cells are aging roughly at the same time, then you will look like you're aging. And that leads to death. And so we call that cell deterioration, cell senescence, and that's the beginning of the end. And so that's a natural process of our cells reproducing over and over again throughout the animal kingdom. Most animals have this same aspect of what telomeres do. There are some animals that are a bit different with the way their cells interact with telomeres, but we're just keeping it the basics now relevant for us. And then there is a good machine though. So I know I use the word machine, everyone's saying, I thought we were talking about biology. Yeah. But the best way to describe it is that our cells are full of lots of machines, things that make things, if that's what a machine often does, something that makes something or helps build something, puts things together. There's a machine that actually tries to thwart the telomeres getting short. And this is very important to know.
So this is a good, like, we want these machines.
We want these machines.
Shorter telomeres is aging. Let's go and stop aging so fast.
Yeah, that's right. Okay. It will actually try to reverse that process. And some animals, what seems to be the key to why they live so long is these machines that reverse, we call them, they're complicated names. One's called telomere reverse transcriptase, TERT.
Okay.
Like Ming, it's nice and short. So some of these animals, they seem to have really good machines like TERT, and there's another one, Turk, and they do a great job of maintaining not just the length, but the quality of these telomeres. And that seems to be the key in why some people even live longer than other individual people.
Yeah, I have heard of some, I think it's genetic diseases is the way they phrase it. I'm not sure. You have to correct me if I'm wrong, but genetic diseases where people age very quickly. Is that? Do you think is that related a little bit to the telomeres, or is it a bit different?
Sure.
Or?
And well, I think it's more important to note that it's related to the beginning of our conversation. So we were looking at going back in time, imagining those people living so long, as if aging goes so slow. So we're asking, if you like, figuratively to them, how come you age so slow?
Yeah.
But if their souls are alive and looking down at us, they'll be thinking the reverse. Why do you guys age so fast?
Yeah.
And so let's talk about these genetic diseases that speed aging up. Now, I realise there may be some people in the audience who might have one of these diseases, or know of family members that have. So understand this isn't a topic that's fun, for some people this is really cutting it. So these diseases, we call them progeria. That's the umbrella term. Pro meaning fast, if you like, and geria meaning the process of aging. So there's a bunch of diseases like this, and we'll just talk about two. One's called Hutchinson-Gilford, named after two people, Hutchinson and Gilford. Children born with this disease, they die by the time they reach puberty, and they die because they've rapidly aged. That's incredible when you think about how long it normally takes for us even to feel like we finish maturing, sometimes in our early 20s maybe. There's another, and that disease is pretty rare. It's about 1 out of every 8 million people. So thankfully it's rare. There's another disease called Werner. Now, that disease, before I move on, what's fascinating about it is that they had looked at the genetics of these people. 18 out of 20 of them, there was only one letter wrong in their genetic code.
Well, and you mentioned like is it 3 billion letters or something?
Yeah.
So one
letter.
Yeah.
Yes, our DNA seems to have areas of it where it can cope with letter changes and even maybe some bigger changes, and it looks like it's actually designed to do that. That's why you're so grateful that you don't look like me, because there's parts of your DNA that are able to change and have built-in variability. But there are other parts that are really sensitive to change. So you just change one letter. All of these had the same one-letter change. If I remember rightly, I think it was a GGC, and it changed to a GGT. Because they're all 3-letter words, for 18 out of 20 of them. So there's obviously some other mutations that cause a dysfunction. So that's important to keep in mind, that a very small change in our massive genome has caused rapid ageing that led to death. That's a take-home message, I think.
Right, so that kind of means, like, it's possible. It's an example, but it's possible that there weren't too many genetic changes to go from hundreds of years old to ages to now around 100 years on average.
You said it very well. There's another disease I'd like to briefly mention, and that's Werner syndrome. Werner syndrome is a progeria. In this case, the disease doesn't seem to cause much in the way of aging hastening until they hit puberty. And then, unfortunately, by the time they're 40, to most people, they would think they're looking at someone who's about 80. Once again, a very sad disease, a little bit more complicated genetics. It's something that happens on chromosome 8 and in one gene called WRN. And so once again, not a massive amount of change that's caused a speeding up. And the link to the telomeres is the fact that although we've classically have been taught to call these progeria syndromes, they're actually calling them telomeropathies. So telomere diseases. They're actually saying the telomeres aren't just associated with aging, but there's something about them that's causal. So that there's some aspect of telomere dynamics, the length and the quality of them being crucial to whether we are going to be aging fast or not.
If you're enjoying this interview so far, you might be interested to know that we also produce the world's most widely read magazine on the creation-evolution debate, Creation Magazine. It's packed with beautifully illustrated articles showing how real science supports the Bible. It's designed for the whole family and is a great tool for strengthening your faith. Sign up now to receive 4 issues per year. Follow the link in the description. I think I'll have to learn more about telomeres. It sounds like a very interesting area of research.
No.
Is it fairly recent area of research?
Yeah, and more has been discovered. So, 2024, I think it was just last year, I was reading a thesis of this woman, brilliant thesis. I can only remember her first name, Svetlana. But she was looking at what she calls genetically determined telomere length. And in her massive study, really brilliant PhD, she shows that genetically determined telomere length looks like it's very strongly causal for 2 different types of diseases. So one type of disease are the ones that we might associate with aging, diseases of the heart. Not everyone realises a lot of heart diseases are basically your heart's getting old faster than the rest of you. And then some immune diseases, and then some diseases to do with hormones. So those people who have their telomeres shortening faster than the others, or perhaps their quality changing as well, of the shelterin, that protein around the outside.
That's like you described it like a plastic coating.
Yeah, the plastic, that's right. Perfect, yeah. And then there are other people whose it seems to be a little bit of the reverse. It seems that some of their cells, their telomeres, are not shortening quick enough and when they're programmed. So this is complicated, but there are cells in our bodies that are sometimes programmed to die only about in every 11 days. And this creates turnover. And we want this. Everybody wants turnover. You don't want to leave food on the shelf for a long period of time. Equally, we don't want to sell in our body pumping out some product when it's getting past its use-by date. So the cells have been, we'd say, designed by God so that there's this process of cell death that kicks in. And we call this apoptosis. So you want this to happen. And what happens, unfortunately, for some people, mutations come along and they prevent this apoptosis, this programmed cell death. So those cells keep living on longer than they should. They might be producing a worse product than before. They might be occupying a bigger space than before. And we call these cancers.
Yeah, that's interesting you mentioned that. I did another interview with another biologist, and they were talking all about the that mechanism of apoptosis and how important it is for understanding cancer research and things. So I'm sure people can, if they want to look more deeply or dive deeper into that topic, we've got another video on that. That's
I'd love
so
to.
fascinating.
I'd love to. Yes.
Well, I might actually bring it back to the Bible now, and so we understand a few mechanisms that the aging process can happen, but like, does it make sense in the way that we see the ages? Like you mentioned this graph where it's like, the ages are sort of course, the graph's not in the Bible. We make the graph out of what's recorded in the Bible, but you've got these ages of about 900 years, and then they start to drop off after Noah's flood, and it's a particular, like it's not all over the place. There's a particular pattern. Can you talk about that?
Sure. And so you're spot on there in that we use the data just like you use any other data you've collected from the field about the length of a shark, for instance, and then we make graphs from that. And this graph looks like a nice straight line with everyone living to about 900 years to the time of the flood. So then it drops off in a steep decline and then it flattens out like a curve. We call them exponential curves. And in biology, they're often exponential decay curves, but you can have other ones. So the question is, given that there's a biological way of understanding how possible it was for people to live so long, is there a biological explanation that accounts for what the Bible describes? So in other words, typically people look at the Bible and they say, well, is there any evidence that this bit in the New Testament is true? Like it mentions a town. And then people go and dig up the sands or dig under an existing city and they say, hey, here's this town. So we're used to the idea of looking for evidence to see whether what the Bible's talking about is reasonable to believe. It can never be proof, or it's got some backup. And so biologists that are Christians are really fascinated in trying to work out how can we explain the data that doesn't require God to be doing some miracles every second in every person's life for 900 years or doing something different after the flood.
I think I know where my question would be. The graph, it goes 900 years and then it drops off and it starts dropping off. Why is there a change here after Noah's flood?
Sure. Well, you said the key word, Noah. So when we read in the Bible that Noah was 500 years old and then had sons, that doesn't mean they were his first sons. They're the sons that are worth mentioning as far as the author of the book of Genesis was concerned, or those keeping the records. So Noah was 500 years old when he gave birth to 3 sons. These are the 3 sons with their wives and Noah's wife that were rescued by building a big boat, a big ark as we call it, funny word, like massive vessel. And they were the ones that came off the ark. Everybody else, unfortunately, was wiped out because of their evilness. And I'd love to talk about that very shortly too, about is that sort of reasonable thing for God to do.
I'll bring that back up soon.
I hope so. So we've got a 500-year-old man who is towards that end of that 1,500 years gap since Adam and Eve were made. And at the age of 500, he's responsible genetically for 3 sons that are on the boat. So we're going to have to talk about sperm and ova. So this is a really important and interesting aspect of biology. So what's fascinating is when a woman is born, she's born with all the eggs, all the ova that she's ever going to have. Us men, we're way behind the 8 ball.
Okay.
We're not born with all the sperm we're ever going to have. We don't even start producing it till we're hit puberty. And then once we hit puberty, there's this process of making sperm that is a little bit like photocopying a text and then photocopying that photocopy and then photocopying that photocopy and so on. But I'll first talk about more of the detail. So we have these cells called spermatogonia. And so if you are a boy growing up and you hit puberty, around that time, the cells that will make your sperm have already been through about 30 multiplications. So think of 30 photocopying.
Photocopies, yeah.
Yeah.
Okay.
And so that's at puberty, already 30 times. When you're 20 and getting married, as some people do at the age of 20, or even not getting married and having a child, your sperm have now arisen from cells that have been photocopied 150 times. When you're 70, it's 1,300 times.
Okay.
Yeah. In fact, when you're 40, it's already 600 times. And so every decade that you wait to have a child, or every decade before you're able to have a child, your sperm, if you like, have been coming from cells that are a photocopy of a photocopy of a photocopy.
Yeah.
And unfortunately, every time a cell divides, there's an opportunity for mistakes. So that's the first reason why an old man's sperm is not as good as a young man's sperm. The second reason why is with all these divisions, the engines that go about repairing the mistakes, once again, the machines, so there are these machines that are going up and down the DNA looking for mistakes. Unfortunately, those machines themselves start to develop faults. So not only are you developing more faults, but the repairing machines are going downhill. And then if you're a bloke in some parts of the world, you might be smoking, and that causes mutations, but you've got photocopying still going on.
Copying those
mistakes. And so really, women, if you're a woman listening to this, try to make sure you're marrying a younger man who doesn't smoke, who exercises and is fit, and you're likely to have enormously beautiful children like I'm sure you were once. Well, you're still a good-looking man, I'm sure. So then we got this process of going on. Now, where does that relate to Noah? So Noah was 500 years old.
There's a lot of photocopies.
That's a lot of photocopies. He had one big advantage to us, though. His lineage was generally a purer lineage, less mutations in his DNA. So every time we have another human generation come forward, in general it's believed that they have an extra 100 mutations to what their parents had. Some people say even 300 mutations.
So does that mean, like, so over time, so people who lived a couple of thousand years ago, since then we've added on more and more and more mutations. So the human population now, on average, just has a greater collection of mutations. And go back, they would have much less, a lot less mutations.
You said that really well.
Okay.
And of course, if, as Christians believe, Adam and Eve were made perfect, there were no mutations. And probably as time went on, because God miraculously intervened in a negative way, did something to the genetics of Adam and Eve so that their repair engines perhaps weren't so strong, so that their telomeres were no longer able to sustain themselves infinitely, like remember that little animal I mentioned, the hydra, where it really does seem to be immortal. In fact, a scientist was given $1.2 million to try and study how does it do what it does.
Yeah.
I'm surprised he wasn't given $10 million. Well, maybe he was given a bonus if he worked it out. Anyway, so we have this great pure lineage. But Noah is still a 500-year-old man.
And he's already accumulating.
He's accumulated some mutations, and then his sperm have definitely accumulated a lot of mutations by the time he's 500 and giving birth to the first of those 3 sons. What's fascinating, though, is that accounts for why Noah's first son lives nowhere near as long as Noah. Because Noah lived, that typical 800, 900 mark. Shem's only already around 600 or 500.
And so that's where it starts to drop.
That explains the first drop. But then the next question is, why is there a continual drop? Why doesn't it plateau for a bit and then drop again? And this is when history comes to our help. Unfortunately, humanity is not nice. I know that I'm not a nice man through and through. God's made me new, but I still know there's some dark cells in my heart, even though he's given me a new heart. But I know how bad I can be. I've been in countries at war, and I see what people can do when they go to the hospitals. And that's never changed. Our basic human nature has not changed. So you imagine that you're Shem, or one of Shem's first group of children, and you're all living very long, and you give birth to let's say a child when you're 20, and you could be giving birth to hundreds and hundreds of children, just like Noah. But these children are also having children very early, and then those children having children very early. So very quickly, Shem is a standout, or those first bunch of kids are standout. They're living, 400 or 600, but there's all these other people further down the track who are now only going to be living to, say, 200, looking back up and maybe meeting Shem or his first lot of children saying, you guys must be gods.
Yeah,
You're excellent at fighting because you've had lots of experience. You're excellent at making weapons. You know the best tree to make the weapons from. You look healthy. You're still having sex with all the young women. You've still got your first wife and still having sex with her and having children. And this is what we see in history. Genghis Khan was a great example. So Genghis Khan is this great warrior. He and his warrior hordes are responsible for the deaths of about 40 million people.
Wow.
Because he was not nice to women, and not only that, he had multiple wives and had large numbers of concubines. He had many descendants. Plus, he was killing many of the population's men. So that's why they say, based on genetics, this is scientific studies, not archaeological, historical now, biological studies, that probably 1 in every 200 men on Earth can be traced back to having DNA in common with Genghis Khan.
Wow.
But how did that work? What's fascinating is that the empire didn't pass to all his children equally. So he had a favourite wife, probably his first wife by choice, and that woman's children, they were given special status. So they were the only ones who, as descendants of their father, could actually own vast amounts of his empire. So maybe Shem's descendants were the same, that they also were giving birth to children when they were very old, but it was to their first wife. And those first wife's children that were born very old, maybe they were the ones that once again passed on this damaged DNA, that maybe by the time they were 400 years old, their sperm had been copied and copied over and over again, and you have this accumulation of genetic damage. In fact, this is so marked that we have a term for it. So when we look epidemiologically, in other words, when we look at large numbers of people with a particular disease, we can see that men who are giving birth later in life, their children have a much greater risk of congenital deformities and other diseases, and we call this patriarchal age effects. So this is a well-known and well-studied branch of science, that our sperm really do get damaged, and so the probability of you having a child that's not as you would like it to be, it has increased. It is a probability thing. Some men at the age of 70 give birth to perfectly normal children. But it's a probability situation.
Okay, I'll see if I can, just summarise this for myself so I understand it. So we've got Noah's flood, and we've got Noah who had children very late in life. For that lifespan that he had, like 500 years. And the accumulations of mutations, they're already building up towards Noah. And within his lifetime, the sperm is actually, it's got photocopies with errors accumulating over that time too. And so his children could have more mutations and genetic defects, which can relate to not living as long. And then now they're already young, living to not quite as old of an age, then the same process happens to them. And you step down another age group. And so eventually, I think that's where that curve comes from, is that it repeats itself again and again and again. But then eventually it flattens out where we are. And so that flattening out, I guess the process only continues so far,
Yes.
and other factors are what cause us to die, other than the
You've summed it up
reduction.
really well. I called it an exponential decay curve, and that's what's fascinating. When people look at this data and they say, is it real or not?
Yeah.
Well, there's several ways of looking at it's real, and one way is mathematical. And so just like you can have a formula that if you follow and then use that formula to plot on a graph, you can end up with a circle. There are formula that if you put different numbers in the formula, you won't end up with a circle because it's a different formula. You'll end up with a curve.
Yeah. So, okay, I think I see where this is going.
Yeah,
Could the author of Genesis, or I don't know, maybe the author of a bunch of books in the Bible, or an editor later, could they go in with their formula, exponential formula, and go, all right, this age, this age, this age, this age, and the numbers, mean something different to their actual ages?
Yeah, well, most people would realise that, although they weren't ignorant people back then, mathematics didn't seem to be an advanced skill back then. And we're looking at the intersection of mathematics and biology. What we see in biology so much is exponential curves. We don't see straight lines going down at steep slopes. We don't typically see straight drop-offs. We see exponential decay curves. So, for instance, if you're smoking marijuana, and I want to study the effects of the main component, which is called THC, tetrahydrocannabinol, then imagine I've got something that's taking blood samples from you every hour, and I'm measuring how much THC you still have before your body breaks it down into something that's not longer going to give you a kick or alter you psychologically. So that's an exponential decay curve. Every hour that goes on, the amount of THC in your bloodstream is dropping through an exponential decay curve. We see it everywhere. We see it with populations that are affected by viruses. Now, the ancients didn't have an understanding that this is what biology does.
Of exponential decay curves in biology. Yeah.
And they wouldn't have, it's unlikely that anyone had an understanding of how to do the mathematics to make an exponential decay curve fit a bunch of dots.
Yeah.
It'd be unreasonable to think that anyone would even have a motivation to do that.
Yeah.
Well, why would you want to do that? What's the benefit? There's no understandable reason for creating that sort of false data. So we've got all these reasons for thinking that, well, this is real maths. And what's fascinating is how well those dots will fit on a particular formula. They fit within a variation of statistically it's called a variance of 4%.
Yeah.
That means that formula captures the relationship between the generation and the decline in age with a really tight fit.
There's not too many like ages that are so one example of an age that would be way off is Enoch.
Yes.
In the first ones, he's 360 odd years old, and then he gets taken up to heaven.
Yes.
So that's an anomaly.
Yes.
But you're saying the percentage fit once we get to the exponential side,
It's extraordinary.
we don't get many anomalies. It's pretty well
Yes.
what you'd expect according to the genetic side of things.
It's exactly right. In fact, I would encourage everybody to plot the data themselves, which is easy to do. You just put in a spreadsheet first and then tell Excel or whatever to make it into a graph. Or look up a name called John Sanford, a geneticist who used to be at Cornell University, or a guy called Walter Mackhouse. He's a professor of brain and cognitive sciences that wrote a paper. Walter Mackhouse was looking at, well, is there any indication at all that these numbers were fabricated? So he did it a different way. He was thinking, well, if I had to come up with random numbers, surely I would pick numbers between 1 and 9 equally. And then he found out, the statisticians have found that our brains don't do that. If you ask a bunch of people to randomly pick numbers, certain numbers they pick much more frequently than they pick other numbers. So that's the sort of maths that he looked at with the data in that makes up that curve. And he said there's no sign of it being fabricated data. It doesn't necessarily mean that there's signs that the data is real, but fabricated data would typically look like this, and it doesn't look like that. And he gave about 4 or 5 mathematical tests. And so great paper if you love maths.
Yeah. That sounds good.
Yeah, it is good. And John Sanford, he's a former geneticist at Cornell University, still very active geneticist. He then dovetails that sort of mathematical aspects with his vast knowledge of genetics. And if you're watching this on Creation Ministries International and you typed in telomeres, Telomere, you're probably going to get some great hits about how that deal with some of this topic. Maybe not quite the same depth, but maybe sometimes more if you go to the technical journal, that's for sure.
Yeah. Fantastic. Yeah. So so the curve, that makes sense. It's not just some fabrication. It's what we'd expect in biology, given what we know about genetics, and if things started with perfect genetics with Adam and Eve, and then the Noah's flood with the patriarchal drive. So that all makes sense. But I have heard some people talk about one of the ages is Lamech, and it's in this passage here. So Genesis 5 verse 31 says, "Thus all the days of Lamech were 777 years, and he died." And I've heard people talk about how 7 is a very symbolic number in the Bible, or it has extra theological meaning than attached when it's used in the Bible. Some people are saying 777, that's clearly not a real age. That must mean something symbolic. What do you think about that?
I think that's very selective. We would call that cherry picking, because you look at all the different types of numbers each person has. There's a number for when they gave birth to their first notable child. Doesn't mean they didn't love the others, by the way. The age that how many years they lived after that, and what their total age was. So if you were to read what the Bible says about Lamech, it's not all 777 or 333. There's a lot of ring of truth in the data. You look at how you got all these people living roughly 900. And if someone said, that's because they're trying to look back at the glory days, they're trying to paint a picture that they were the best ancestors you could ever hope for. Well, why is it that the best ancestor of that lot, Enoch, who went away in his 300s, he never actually died. God whisked him away earlier.
Yeah.
But wouldn't it make more sense, if you're playing with the truth, to have Enoch living 3,000 years, or at least 1,500 years? Why would you pick the best of the best? The best of the best, the Americans might say, in the armed forces, the star of your show. Why would you have him disappearing off the face of the earth so early? Especially when everyone's so bad. You think, leave him here, please. We need somebody that's good. Yeah. So that's what I mean by the ring of truth.
Yep.
When you and I first read this, you read, and I did too as a child, because I was exposed to the Bible as a child. And then growing up, and you hit your teens, and you start thinking about things, not just your own self, and you read 900 years, you go, 900 years, you got to be kidding, 900 years, really? And that's exactly the case, that it's really, yes, you should be surprised. You should come to the Bible willing to be surprised. But then you should also be willing to put some effort into seeing, is there any chance that this is real?
Yeah.
And then how does it relate to me? How does any of this relate to anybody living today in Ukraine, or living in Sudan, or living in Australia? That's the importance of what we're talking about. And I would say the relevance is we're trying to see whether the Bible's description of how we came to be on earth and the Bible's description of humankind is reasonable. And if it's reasonable there, maybe it's reasonable everywhere.
You mentioned at the start that God did something from the time of Adam and Eve to change us so that death was in the world, like a punishment. Is God going to do something now in the situation we're in to save us from that death?
So there's two things really you're talking about there is, one, the punishment, and two, was there a rescue? That's not to say that God was caught out by any of this. I don't believe that he didn't know what was happening in the future. Of course, that's part of the definition of God, is that he knows everything, including the future. So the first aspect of it is, I had actually had a friend text me this. He thought that dying and death is a terrible thing, and no loving God would actually do this as a punishment. I disagree, because I see the ability for men and women to do great evil as their life goes on just increases, especially if their ageing process is not also tracking with the decades going past. So we could end up with that situation where you might have some very powerful individuals on earth who are therefore able to do a lot more harm forever and ever. So you could think of people like Stalin and Lenin, who generally are understood to be mass killers, that most of us probably wouldn't want them to be able to do that for 100 years, let alone 900 years. So there is some part of us that doesn't want this world to be the way it is. There's an acknowledgement that there's an evil in this world and that we're unable to make it a better world. There seems to be that acknowledgement. There's this understanding that we can't be the person we want to be every day of our life. For some people, they already have an awareness that as the decades going on, they're getting more stroppy. We often have in various languages these idioms about a stroppy old man, and some men will resonate with this, and probably some women too. They find that they're getting difficult to be what they want to be. So I think there's a sense that we know that we're not what we should be, and that this is not really the perfect home that was made for us. And that we can see that there's some benefit, if you want to put it that way, that we don't live forever. But there's also that other part of us, that very human part of us, that doesn't like seeing someone's life end here on earth. As Christians, of course, we don't believe it's the end, but we do believe it's the end of their time on earth and that they'll face judgment afterwards. And this is something that the Bible is very frank about, and something I believe in, and certainly this is a very basic belief of Christianity, that one day we die and then we face judgment. So we sort of have looked at, just going through my mind, this idea that, okay, I can understand that there's this death in the world, that it came because Adam and Eve disobeyed God, and as punishment because of that, there's this sin and this fact that we die. And sin being separation from God. That's behind everything that's evil. Death was not something that God designed the world for. Adam and Eve were meant to live forever. We were talking about that at the beginning. Thankfully, though, the rescue has already been talked about a lot as well. And of course, that's Jesus. You know, as I said, I believe he's alive and well, and more than that he intervenes. That you can talk to him whether you already know him or not, whether you already love him or not. You can talk to him. You can ask him for help. You can ask him to make you born again, if you like. We were talking about being born before. You can ask him, can I be born again, please? I need more genetic material, something new and something different. Make me new. And he honours that because he loves us. He is a loving God, and by that I mean that he wants to be in relationship with us and wants us to be, it's hard to say this in a way that doesn't sound strange. We're at our best when we're with him. Mm. And therefore we can only ever be our best when we're with him. And on this earth we can't be close to him as we will be in the next life. But everyone's available. Everyone has available this access to Jesus. Doesn't matter what your mother tongue is, what language you speak. Doesn't matter whether you're rich or poor. Jesus is there ready to listen, or is listening. I shouldn't say ready to listen. He is listening, whether you like it or not. And he's so keen to give you a new lease of life. We talk about being born again here, but we also want to be in heaven in the next life.
That's just so powerful, that good news that we've got salvation and that we can live forever with Jesus if we accept him in our lives. Well, thank you so much for sharing all this wonderful information to help us understand that we can trust the Bible. Not just the start, but because we know that's true as well, the end as well, and all we hear about hope and with Jesus. I think that's fantastic. Thanks so much for joining us.
Oh, you're very welcome. Thank you.